Okay, so we have to find at what point on the curve f of x equals x over root x squared plus 1, the tangent that has gradient 1. So we have to find the point on this curve. So first thing we have to realize is that we need differentiation. So if you haven't done differentiation yet, you can skip this video and then come back to it when you have. So let's first write this out in a way that's easier to differentiate, aka get rid of the square roots and write in terms of indices. So that becomes x over and then x squared plus 1 to the power of half, because that's what square roots are raised to. Now, we need to use the quotient rule because we have a fraction. Quotient rule is, let me write in a different color, dy over dx is equal to v times du over dx minus u dv over dx over v squared, assuming that we have u over v as our function. Okay, now we can just input into this formula. So in this case, let's just establish what our v and u are. So let me change the color. U is equal to x, v is equal to x squared plus 1 to the power of half. And we may as well find u prime, or as they've written in this notation, is du over dx, which is equal to 1, and dv over dx is equal to, and we just use chain rule, so it become half times x squared plus 1. I'm just using a very quick version of the chain rule, but you can do it slower if it's better for you. And then this becomes x times x squared plus 1 to the power of negative half. Okay, so we've got all the information we need. Now we just really need to plug it into the formula. So it wants us to put v in there first. So v is x squared plus 1. Let me just put prime x is equal to x squared plus 1 to the power of half. And then times by du over dx, which is 1. So we don't need to write anything. That's subtracted from. And then u is just x. And then we multiply that by dv over dx, which in this case is x times x squared plus 1 to the power of negative half. So that gives us x squared plus 1. Oh, wait, sorry. Just give me a second. I forgot that. We need to divide this by v squared. And v squared is just the square root of x squared plus 1 to the power of 2, which is just x squared plus 1. And this gives us x squared plus 1 to the power of half minus x squared times x squared plus 1 to the power of negative half. And at this point, it's worth just getting rid of the powers and making it easier for us to see. So x squared plus 1 to the power of half is equal to the square root of x squared plus 1. And that's subtracted from x squared times x squared plus 1 to the power of negative half, which is just x squared over square root of x squared plus 1. And that's all divided by x squared plus 1. Now, to evaluate this, we should make these terms over here the same denominator. So we can multiply this first term over here by x squared plus 1, root x squared plus 1, which just gives us x squared plus 1 conveniently. So we have x squared plus 1 minus x squared over the root of x squared plus 1 divided by x squared plus 1. And now we can just use division. So we can just use fractional division to give us, that's equal to, let me just write, and that's equal to x squared plus 1 minus x. Let me just simplify that down to 1. 1 over the square root of x squared plus 1, which is multiplied by the inverse of this. So that gives us 1 over x squared plus 1. So that's equal to 1 over x squared plus 1 to the power of 3 over 2. And now we need to find the tangent that has gradient 1. So we can just equate this to 1. Now we multiply everything by x squared plus 1 to the power of 3 over 2 to give us x squared plus 1 to the power of 3 over 2 is equal to just 1. And now if we remove the power, it still becomes 1 because anything raised to the power of 1 is, no, anything with the base 1 is just 1. So that becomes x squared plus 1 is equal to 1. Bring the 1 to the other side, so it gives us x squared is equal to 0. Square everything, and x is equal to 0. So the x coordinate is x is equal to 0. Now we need to find the y coordinate. So we just simply put it into this curve. So f of 0 is equal to 0 over root of 0 squared plus 1, which is still 0. So the point on the curve where f of x has a gradient of 1 is the point where x, y, and that is equal to 0, 0. So the origin.